Okay, I'm recording now. Okay, and I'll deal with the YouTube live thing later. So let's get started. Let me put you on the document camera now. Boom, there we are. Okay. There's the document camera. So today we're going over more on slope, which is in 2.4. There's two main things in this section. There's parallel and perpendicular lines. Actually, I'm going to be lazy. For parallel lines, you can just write that. For perpendicular lines, you can write that. So we'll say parallel and perpendicular lines. And the other topic that we covered today, which I'm going to stick a little more on, is average rate of change. Okay, average rate of change. I'm going to move this thing a little bit so it's a little more ergonomical for me. Okay, so first let's start with this parallel perpendicular lines. So first off, if we have two parallel lines, the main thing we need to know is parallel lines have the same slope. Okay, they've got the same slope, which makes sense. If we've got two parallel lines on a graph, right, they've got the same exact slant, so they're going to have the same exact slope. Perpendicular lines, though, are a little different. When perpendicular lines hit, let me see, I've got some markers going on in my pocket. When perpendicular lines hit, they're going to have opposite sign slopes. Like, look at the black lines compared to that blue line. Now, it's not perfectly perpendicular, but let's say it is. That black line's positive, that blue line's negative. And so what happens, this happens every time, actually. The signs change, and also the reciprocals of each other. So it's not the same slope, it's actually opposite reciprocal, okay? Opposite reciprocal slopes. So let's look at some examples and how your book kind of brings this in this section, and then I'll go over what that opposite reciprocal thing means. So let's say, and this is going to be very similar to section 2.3, right? It really is like 2.3b. That's what this section should be titled, honestly. But let's say we have a line that goes through -1, 2, and we're parallel to y equals 3x minus 4, okay? We're parallel to y equals 3x minus 4. And we want to find y equals mx plus b. Well, if we're parallel to this line, if our line, we know it goes through -1, 2, and we're parallel to this line, we know we're going to have the same exact slope, right? So because we're going to have the same slope, we're going to steal the slope from that line. So the slope from that line is 3, right? Because it's the coefficient in front of x. And we know we go through -1, 2. We've got a point, we've got a slope. So I've got to put this in point slope form first, right? If you did the homework and you watched the video from last lecture, I went over this extensively. So I'm not going to go over it. I'm just going to show you how to do it. So y minus 2 equals 3 times x. Now it's a minus a -1, so y plus 1. And then to get it in slope intercept, I've got to solve for y, right? Distribute the 3, and I get y equals 3x plus 3. Add the 2, and I wind up with y equals 3x plus 5, okay? Now look at this. We have these two different lines here, right? This, I believe, is my solution. Now, if I looked at these two lines and I asked, hey, asked myself, are they parallel? Yeah, they're parallel. They've got the same exact slope. That's a 3. I didn't mean to write that one there. They've got the same exact slope of 3, and they have opposite, or not opposite, but they have different y-intercepts. So yeah, these lines would be totally parallel, okay? And then does it go through -1, 2? Well, yeah, if I plug in -1 to the x value, -1 times 3, that's a -3, plus 5 gives me back y equals 2. So I know that that line is parallel to y equals 3x minus 4, and it goes through -1, 2. We found our line, okay? And the first part of this, from here on, was all 2.3 stuff, right? That was all 2.3 stuff. So very, very straightforward. Okay? So now let's look at a perpendicular question. So perpendicular question, same kind of question, except it's going to say, okay, let's say we go through 2, negative 1, but then we're perpendicular to y equals 2/3 x minus 4. Okay, 2/3 x minus 4. So we're not parallel. We're not going to steal this slope, right? Instead of stealing it, we're actually going to do the opposite reciprocal. So our slope, instead of 2/3, you're going to flip it. So it's going to be 3/2. And instead of positive, it's going to turn negative. Okay? So these would be perpendicular slopes. Notice you flip it. So instead of 2/3, it becomes 3/2. And you change the sign. Instead of a positive here, which we don't write it, but instead of a positive, it turns negative. And we know we go through 2, negative 1. So then it turns into stuff we did from 2.3. Okay? So let's do that. So we get y plus 1 equals negative 3/2 times x minus 2, right? Distribute the negative 3/2. We get y plus 1 equals, now this is going to be negative 3/2 x. 2 negatives make a positive. Now, the 2's cancel. If you want to multiply this, this becomes 2 times 3, which is 6, divided by 2, which is 3, right? And then we subtract 1, and we get y equals negative 3/2 x plus 2, okay? And now look, I'm going to look at this equation, and I'm going to ask myself, just like I did before, instead of parallel, though, I'm going to say, hey, these two equations are perpendicular. They have opposite reciprocal slopes, right? So I know the two equations are perpendicular. And then I'm going to say, does it go through 2, negative 1? Well, 2 times 3/2, that's negative 3, plus 1, that's a negative 1. Yeah, this checks out, okay? So this line is perpendicular to this line, and it goes through 2, negative 1. So I know I found what I'm looking for in a way, okay? Okay. You know what? I forgot to ask about homework from 2.3. I'm going to stop here. I'm going to ask you guys if you had any questions from the homework in 2.3. Because really what we're going over is 2.3 stuff in a way.
I have a question.
I'm listening.
So I don't know if the question was different in the book that I had, but
Yep.
for some the number 87 with the ABC, that was the first question I tried, and my C came out negative
Okay.
for some reason, and I know it was supposed to be like a percentage and like be
You're only
higher
expecting
than what
yeah.
I had to be.
Okay. Let me come back to that one, CJ.
Okay.
Because that's not really what we're doing here. No, I like that you asked it though. When I get done with this lecture, I'll definitely go over that. Because that's a good question. And I'll hit that. Yeah. Did you have any problems with the ones before it though?
They're pretty easy.
Yeah, it's pretty straightforward, right? Once you get the habit, or once you get the kind of formula going, it's pretty straightforward. Yeah. No, I don't mind going back over 87. Let's just wait till, yeah. I know I told you I would do that, but that's more of, in that. I like that question though. Okay, so let's do another one of these, and I want you to try it now. I'm going to pause it so you can try it because I'm recording and not on YouTube Live. This is number 12. It says it passes through 5, negative 9, and it's perpendicular to x plus 7y minus 12 equals 0. Now look, I'm going to start this one out, and I want you to finish it. But if we're perpendicular to this, we've got to solve for the slope here, right? And you solved this in 2.3. So we got to solve for the slope here. So I'm going to put this in slope-intercept form. I'm going to add the 12 and subtract the x from both sides, right? Then I'm going to divide by 7. And I get y equals, now this can be written as negative 1/7 x plus 12/7, okay? Negative x over 7 can be written as negative 1/7 x. So now think about this. We're perpendicular to negative 1/7, right? So we go through 5, negative 9, and we're perpendicular to this. So that means our slope is going to be, if you flip it, it's going to be 7 over 1. And since this is negative, it's going to turn positive. So our slope is 7, okay? So I want you to try this. We go through 5, negative 9. Slope is 7, and I want you to find y equals mx plus b. And I'm going to give you just a few plays. So we're recording now. We get y, I'm going to start over. So y plus 9 equals 7 times x minus 5, right? Distribute the 7, we get 7x minus 35. Subtract the 9, we wind up with y equals 7x plus, oh, not plus, y equals 7x minus 44, right? Y equals 7x minus 44. Now look, these two lines are perpendicular, right? And if I plug in 5 here to x, 5 times 7 is 35, minus 44 gives me the negative 9. So I go through 5, negative 9, and I'm perpendicular to this line. So I know this has to be the solution, okay? Any questions about that? I feel like that's really, that could have been in 2.3. Like other materials have this in the same section as the linear equations because it's a linear equation, right? So next though, or linear function I should say. Next though is different. It's average rate of change. Now, I'll tell you, if you were planning on going to take a calculus class, business cal or cal 1, I would pay pretty close attention to this. Average rate of change. It kind of gets into the idea of the change over a certain amount of time. And calculus really is just the math of change. So it's a way of thinking of slope, but in kind of different terms. To find the average rate of change is really the same as finding the slope. But the thing is, the average rate of change doesn't come from straight lines. So what we're gonna actually do is find the slope of a secant line slope of a secant line, you can say through the graph. Okay? Now look, it's got to go through 2 points, at least 2 points, which that's part of the definition of a secant line. A secant line just cuts a graph by at least 2 points. So let's look at an example where we've got a function and we'll kind of draw a secant line in with a function. Okay? Let's say, I'm going to try to get these digits pretty crisp. Okay. Let's say I've got a function and it kind of does some roller coaster type stuff. Let's say we bottom out there, top out here, here. Okay. Come up, comes back down, and it does something like that. Holy cow, this is a beautiful looking function. Okay, so I'm recording this. Oh yeah, I gotta have this on record. So we can see that it goes through these 3 points, and a secant line just cuts through. Actually, I'm going to choose another point here. Okay. Secant lines just cut through the graph. It's a straight line. So secant lines are just straight lines that cut through the graph. So let's say I wanted to find the average rate of change from x equals -2 to x equals +2. Okay? So the question would look like this. Find, we'll call this f of x. Okay? Find. Now I'm going to be a little lazy here. I'm going to call this average rate of change for f of x from x1 equaling -2 to x2 equaling +2. Okay? Now the way I would do that, now look, there's a formula way of doing this, which I'm going to get to, but if we don't go over how to do it on a graph, you're not going to really understand where this formula is even coming from, okay? And especially if you want to go and take calculus, it'll make more sense with the formula. So what I'm going to do is between -2 and +2, so my coordinates are here and here, right? That's where x equals -2, and that's where x equals +2. I'm going to make this straight line, okay? That is my secant line. Or that's an example of a secant line, okay? And now all I need to do now is find the slope of that secant line. Now I'm going to use rise over run for this one because I don't have the equation and I can see clearly it goes through these two coordinates, right? So if I want to go from here to here, I'm going to have to go up 1, 2, and I'm going to go over 1, 2, 3, 4. So my rise is 2, so the average rate of change. The rise is 2 and the run is 4. So 1/2, okay? So from -2 to +2, the average rate of change is 1/2. So on average, we're rising 1 unit for running every 2 units, okay? That's where this is coming from, okay? Now the thing is, your average rate of change changes, or usually typically changes when you change the x values. So let's see one that maybe has like a negative average rate of change. We'll keep going with this, okay? We'll send another coordinate right here, okay? So now I'm going to go, now this is 1, 2, 3, 4. That's x equals 4. And we'll start at -3 here. Now that's a lot of rising and running, but I'm going to use a different color so maybe it'll be kind of clear. I'm going to send the secant line through here. Okay, so there's my secant line now. This is going to be the secant line for the second question I ask, okay? So there's my secant line, and the question would look like this now. So we'll call that A, and the other one will call B. Find the average rate of change for f of x from, now our x1 and our y1 are good, or x1 and x2 are going to be different. x1 here is going to be -3 to x2, which is going to be a +4 now, okay? So x4 or x2 is going to be 4, and x1 is going to be -3. And notice this average rate of change, it's just the slope of this secant line. This average rate of change, this average rate of change is going to be negative, right? As we're going to the right, we're decreasing. So let's look at it. So I have, if I start here, because that's at -3, x equals -3, I have to go down 1, 2, 3, right? Because that coordinate right there is 4, -1. So I go down 3. Rise 3, -3. And I'm going to run 1, 2, 3, 4, 5, 6, 7. So my average rate of change is -3 over 7. So over this time, I'm decreasing. Actually, I'm decreasing on average from -3 to +4. I'm decreasing on average -3/7. Okay, -3/7. Any questions for this other than, I think I just need to see another example. Okay, I'm going to show you a real world example of this, and we're going to try to pull the data from a graph, okay? And it's very, topical right now. We're going to talk about COVID for a minute. And I want you to put your, this is all a hoax hat on. And then I'm going to want you to put your, oh no, we're all going to die from this hat on, okay? And I want you to put yourself in both of these positions, because when we look at this graph, you can actually feed into your bias either way, okay? And I'm going to show you what I'm talking about. You can feed into your bias either way from this graph. Let me find it real fast. I used it in yesterday's class, and it looked really it's not smooth actually because it's a real graph, but COVID-19 graph just popped up. Yeah, here we go. Okay, I'm gonna have to kind of bring you over into this screen. Let me do screen capture. Hold on. Okay. Share. Now look, can you guys see this now? This is the death. This is a COVID daily change in deaths. from the United States in Arkansas. Okay. And it starts, looks like we had our first one really too in March 24th, all the way to today, which we had 18. Now I need a thumbs up here because I can't see you. Can you guys see this on my screen? Just give me a thumbs up.
Yes.
Okay, thank you, sir. Okay, so now here's what we're going to do though. We're going to take the average rate of change from this graph, and we're going to take it in two different places. And first we're going to put on, this is all a hoax. It's all going away. Think of it maybe not like a hoax, more like, hey, it's not as bad as it looks. It's on the decline, right? So we're going to put that hat on first. So we're going to put it, this is the not as bad as it seems group, okay? And if I'm in this camp, I'm going to try to find two coordinates on this graph that make it look like it's declining, okay? So if I chose two coordinates that kind of look like it's declining, I'm going to choose this date, which is July 28th. Okay, well, first off, before we get started, we've got to define our X and our Y, okay? My X values is going to be days after July 1st, okay? Days after July 1st. So that means like X equals 1 would correlate to July 1st, right? And X equals 2 would be July 2nd, and so on and so on. So this is really a coordinate on the graph, right? Do you guys see that? So July 28th, there were 20 deaths in Arkansas, 20 recorded deaths. So my Y value is going to be the daily death count. Okay, the daily death count. So for this first coordinate, if we wanted to write it as a coordinate, this is going to be, well, the X value is 28 because it's July 28, right? And the Y value is 20, okay? Because there were 20 deaths that day. But look, I want to show that it's declining. So as my days get larger, I want to show this is decreasing. Like I'm not going to choose September 2nd here because think of a secant line going through those 2 points, guys. Think of a line going from here through here. It would be increasing. And look, I'm in the camp that I think it's not that big of a deal. So I'm going to show that it's decreasing over time. And then we're going to interpret what it means. That's really why I'm choosing this one, because it's about interpretation. So I'm going to choose, let's choose the coordinate right there, okay? Actually, let's do more recent. Let's do right there. September 13th, we had 12 deaths that day. Now, September 13th, okay, I've got to go through July. I've got to go through August. Oh, that's a lot. I don't have no fingers and toes. So let's see. There's 31 days. 31 days in July, plus 31 days in August, plus 12 days, to get to, to get to 13, we'd have to add 13. So September 13th would correlate to 75 for our example, okay? So what I'm going to do really is think of a secant line going from this September 13th coordinate and this July 28th coordinate. So now I'm going to stop sharing my screen. Then I'm back here. So look, do you guys see this? These are my two coordinates, right? I'm just finding slope. That's all it is. So the way you would word this though is the average rate of change from X1 being 28 and X2 being 75, okay? So the average rate of change between here, so that's going to be, now it's just the slope, 12 minus 20, changes in the Y, over changes in the X, okay? 12 minus 20, that gives me negative 8. It's bleeding through. Hold on. No. 12 minus 20 is negative 8. 75 minus, let me get this right so we don't do crazy here. 75 minus 28 is going to give us 47. Okay, so what this means, and I remember this is about change. If I'm going to interpret this top number is the daily death count, right? This bottom number is just days, right? Now I'm going to keep it in that kind of terminology. So what's happening is the average change from day 28 to day 75 was actually negative. It dropped on average from we're looking at 8 less deaths per day over 47 days. Now I'm going to simplify this because it'll make a little more sense as a decimal. So 8 divided by 47. So this would be 0.170, actually negative 0.170 over 1. I'm going to interpret this here. So the interpretation would be from day 28 to day 75, right? We started day 28 to 75. The average change per day. Now, the reason we can say this is per day now is because that bottom is 1 day, right? And this is still the daily death count, okay? So from day 28 to day 75, the average per day change in death count in Arkansas, if you want to put that, is dropping at 0.170, okay? So that means, look, if I'm in this camp, what I've shown is that, hey, if we cherry picked these 2 dates, it actually looks like that we're lowering each day on our death count, right? And if we go back to that graph, it really kind of shows that if all we did was look at those 2 coordinates, it really does look like that. Okay? Questions? I'm going to put on my no, everybody's going to die from this hat next, right? Which, in my opinion, in reality, it's just somewhere in between, okay? But are there any questions about this before I go on to the next example? So, okay, I'm going to leave this kind of up. Now I'm going to share my screen again. Okay, so now if I'm in the camp that, look, everybody's going to die from this. There's the entire state's going to die from this. I can show that as well. And this is called cherry picking your data. If you've heard that, you're just cherry picking the data to fit whatever biasness you're trying to fit. So let's look. Where's my paper? Hold on, guys. I'm running out of paper here. Okay. So I need to pick 2 more days, but this time I want a really high rate of change because I'm trying to show that, hey, this is actually a lot worse than it is. So I'm going to look, let's start here. On July 4th, Independence Day, we had 5 deaths. Now that'll be kind of easy for the coordinate. It's just going to be 4. Remember, 1 was July 1st, so 4, and then there were 5 deaths. So the first coordinate is just 4 because it's July 4th. Now, I want to go from here, and then I'm going to go to this peak right here, right? Notice this. If I go from July 4th, and I make a line, a secant line from here to the 21st of August up here, it's going to have a really high positive slope, right? That secant line would have a really high positive slope, which is what we're trying to find, because now we're in the camp of, hey, this is a lot worse than it actually is. Okay, so for this coordinate, now the day is August 21st, so it's going to be 31 days in July plus 21 days, so it's day 52 if we started on July 1st. And on day 52, we had 22 deaths. Okay, so now I'm going to switch back to a screen here. So this is what the 2 coordinates look like. So now we're really finding the average rate of change from day 4 to day 52. Now look, if this thing was linear, if this graph is not linear, right? It's bouncing around up and down, up and down, up and down. If this was linear, these 2 would be the exact same, because any 2 points on a linear line are going to pop out the same exact slope. But we don't have a linear line, right? We have really a line that kind of occurs in nature. It's going up and down. It's not perfect, okay? So let's look at this. if I wanted to find the average rate of change, it's going to be the y's, 22 minus 5, minus the x's, 52 minus 4. So 22 minus 5, that's going to be 17, over 52 minus 4, that's going to be what, 48? So what happened is over these 48 days, we saw an increase per day of 17 deaths, right? We went from 5 deaths on the 4th day to 22 deaths on the 52nd day. So from day 4 to 52, so from day 48 days later, we saw an increase of the daily death rate jump to 22. Now, so let's really talk about that in terms of a decimal, though, right? Per day. We want the per day jump. So 0.3. I'm rounding this, guys. 0.354. I'm gonna think of it as over 1. Okay. Now this is much different. So like, go back to here. We had a negative per day death rate drop on average for the other 2 coordinates we choose. For these 2 cherry pick coordinates, we've got a really positive, right? I mean, what we're saying here, if we want to interpret it the same way, we would say from day, was this 4 to day 52, the average per day change in death count, daily death count, I should say, jumped 0.354. So it went up 0.354. So we're saying it's increasing daily by 1/3 of a person. So about every 3 days, we should see 1 more person per day die, right? So like if on the 15th we had 16 people that passed away from this, if we go off this, trend by the 19th day, right, 3 days later, we should really have another person that passed away, okay? So if on the 16th day we had 20 die, we should see on the 19th day we should have 21 die. That's what this is telling us. So for every day there's about 1/3 of a person that passes away, which we know that, I mean, that's just dealing with numbers. So if 1/3 of a person passes away, that means every 3 days we should see a jump of 1. Okay. Are there any questions about that? So we've seen it on a graph. We've seen it just with real world data that we kind of pulled from a graph. And now I'm going to go over it equationally. Equationally, it is just like slope. I mean, notice all we did was find slope here between these 2 coordinates. So if I looked at an equation, I'm going to steal, actually, no, I'm going to go up. Let's say we've got f of x equals something really kind of easy, x squared. Okay, f of x equals x squared. And I'm gonna state it the same way. You've got to be given 2 x values, okay? I want to find the average rate of change from, we'll say x1 being -1 to x2 being +4, okay? From x1 being -1, to x2 being 4. Now the equation looks like this, and guys, it is just the slope equation, okay? It's going to be, instead of y's, we're going to use the function notation. So it's going to be y2, that's f of x2, minus y1, which is just f of x1, all over the change in the x's, x2 minus x1, okay? So it's just the change in the y's over the change in the x's, okay? So for this, though, we know the x1 and x2. The denominator is going to be given to us. We've got to find out what f of x2 and f of x1 are, okay? Like if we think of plugging the x's in, this would be f of 4 minus f of -1 over 4 minus a -1. Whew, I should put it like that, right? So it would be f of 4 minus f of -1 over 4 minus a -1. So I've got to find f of 4 and f of -1. Well, f of 4, if we go up here, that's 4 squared, so that's 16. Minus f of -1, well, -1 squared is a +1, right? So 16 minus 1 in the numerator. And on the bottom, we have 4 really plus 1, right? Because it's minus a negative. So we get 15 over 5, so we wind up with 3. Okay? So the average rate of change from -1 to +4 is 3. Okay? That's how you say it. Now for the book and for this question, you just box in 3 and you would be done. Okay? You would just box in 3 and then you would be done. Okay. Are there any questions? Other than, I want to see another one of those. That didn't click right for me at the moment. Okay. So let's do another one. Let's say, now we'll pull out maybe like a weirder looking function. Let's say we've got g of x, and it is the square root of x plus 4. Okay? So I want you to find the average rate of change from, now I'm going to make x1s and x2s that work nicely, okay? Let's say x1 is -3 to x2, which is 21, okay? From x1 that's -3 to x2 that's 21. So I'm going to go through this whole rigmarole again, okay? I'm going to write the equation out. I'm going to plug in what we know, and then we're going to have to find g of x1 and g of x2. So the average rate of change would be g of x2, so y2, minus g of x1 over x2 minus x1, right? And then I'm going to plug in what we know. We know x2 and x1. They have to give us this, okay? I've got to give it to you when I ask you on the test. The book has to give it to you whenever it asks you in the homework, okay? So this winds up being g of 21 minus g of -3 over 21 minus a -3. Question, comments, concerns? Okay, so now I've got to find g of 21, g of -3, right? G of 21, I've got to go back to here. I got to go back to my equation. So it's going to be the square root of 21 plus 4. So that's just the square root of 25. That just winds up being 5. Okay, so we got 5 there minus, I'm going to try to end it before the paper ends. G of -3, that's going to be the square root of -3 plus 4. So that's the square root of 1, that's just 1. Over 21 plus 3, right? Because it's minus a negative. So we wind up with 4 over 24. Is that right? 5 minus 1 is 4. 21 plus 3 is 24. And then we can simplify this. They're both divisible by 4, right? So we want 1/6. Okay. Hey, I finished it before the end of the paper. Do you guys have any questions about this? Silence. And that's fine. The silence, I'm assuming you kind of get a grasp of it, or man, I need to hit this in the homework before I really understand it, but I'm not sure what I don't know yet, right? Because look, math is not a spectator sport, okay? You've got to get in and do it before you really know if you can do it. You got to think, guys, I've been doing this over a decade. I should make it look easy. If you do something over 10 years, it should look easy to someone else at this point. But this isn't that easy, okay? Okay, so for now, like, don't go away, because CJ's question about the question in 2.3 is really good, and I want to go over it. But for homework in 2.4, I want you to do, I would do 1 through, now this is on page 296. 266. 1 through, let's do 1 through 29 odd. So not that much, but they take a little bit of time. So 1 through 29 odd. If you feel like you need to do more, do the evens. And I don't mind going over any questions on the evens. But I want to go back now. So that's homework 2.4, page 266, 1 through 29 odd. Now, CJ asked a really good question. Now, CJ, let me get this right. You said number 87, part C, correct? Excuse me. 87, part C. Now, I'm going to do A and B just to lead us into C, okay? So this is on page 256. It's number 87. And I'm going to do A, B, and C, and then just to make sure we're on the right track. Okay, so let me kind of move this desk around a little bit so I can get the book closer to me. So in this exercise, you will use the blue line for the women shown on the scatter plot to develop a model for the percentage of never married American females from 25 to 29. It says, A, use the 2 points whose coordinates are shown by the voice balloons. Okay, I see the voice balloons now. To find the point slope form of the equation of the line that models the percentage of never married American. Now, females, we're looking at females, so it's the blue line, right? So for A, we're going to use the coordinate 10, 31.1. Now that coordinates, that really what that means is in 1990, there were 31.1% of never married females between the age of 25 and 29, okay? And the other coordinate that it gives us is, I guess, 2000, right? In 2000, there were 38.9% of never married females from the ages of 25 to 29. So it wants us to put this in point slope form. So to do that, we need to find the slope first, right? So slope's going to be 38.9 minus 31.1 over 20 minus 10. I'm going to use my calculator because I just don't like doing decimals. We got 31.1 minus 38.9. So negative 7.8 over 10, right? So that's going to be negative 0.78 for the slope. That's not right. It should be positive. Oh, why did I say it was negative? It's positive. Yeah. Positive 0.78. So so what's happening is each year the increase of never married females between the ages of 25 and 29, it's increasing by 0.78% a year. Kind of neat. Okay, it's kind of neat, kind of showing what's happening with some demographics. Now you can choose either coordinate. I'm going to choose the first one. So y minus 31.1 equals 0.78 times x minus 10. So that's part A. We found the point slope form of that line. And part B has to write the equation for the line, right? Well, we know we just have to solve for y here, right? So what we were doing yesterday, we distribute the 0.78 and we get y minus 31.1 equals 0.78x minus, now times 10, this would be 7.8, right? Then I've got to add 31.1 and I wind up with y equals 0.78x plus, now let's see here, 31.1, oh, clear, 31.1 minus 7.8 is 23.3. Okay, so here's now, I guess they want you to write it as a function. Yeah, use function notation. So it'd be f of x equals 0.78. Now you don't have to write the 0.78, but if you're a nurse, you've got to write it. I know that's a deal. If you want to go to nursing school, you've got to write 0 in front of the decimal. And it's so we don't die from you giving us too much or too little of a drug, okay? So 0.78x plus 23.3. So CJ, are we good to this point? You can give me a thumbs up. Are you there?
I had it messed up, but yeah, I think I got it.
Okay, good. So now let's do part C. Part C says use the linear function to predict the percentage of never married American females in 2020. So what about 2020? Ugh, what a year, Jesus. Okay, so what about 2020? Now you got to think the X value is years after 1980. So our years we're going to use then would be 40, right? So the years would be 40 because 1980 was 40 years ago. So all they want us to do is plug this 40 into this function. So f of 40 is 0.78 times 40 plus 23.3. So let's see here. 0.78 times 40 plus 23.3. 54.5. So the prediction is that by the year 2020, so this year actually, it predicts that we will, there's that females between the age of 25 and 29, that 54.5% of females between the ages of 25 and 29 are not married. Okay, that's all that this, that's all that it's saying. That's a good question. I like that one. I like it because it makes you do a do what you were doing in this section, which is point slope form, y-intercept, right, or slope intercept form. And then it was kind of neat because what you did was you found a trend line, and they found a trend line. If you look at the book, there's two graphs. There's like the actual data, and then there's the trend line that they made based off the data. Okay. Okay. Let me switch here. So, give me just a second, guys. Oh, I'm back. Okay. Are there any questions about section 2.4 or 2.3? Those are the two that we've covered. We're going to go on to 2.5 on, what's today? Thursday. So on Tuesday, we'll go on to 2.5. Nothing. Look for that survey, guys. You're going to have to check your ASU Mountain Home email because I'm going to send it through Blackboard into that email. So check your email by at least this weekend to complete that survey. And again, I guess if you just want to keep doing Zoom, you don't have to fill it out. That's not a big deal. I'm sorry. Yeah. If you want to keep doing Zoom or keep watching the videos on your own, you really don't have to fill it out. But if you want to come into the class, I need you to fill it out because I got to find out how many students actually want to do that. And I want to give you a few days to do it because I know some people don't watch these videos till the weekend. So I'm going to give a few days before I collect the results from that survey. And then just probably for this class, I'll probably have to determine if you're a Tuesday or a Thursday student. Okay. So I'll determine that if I have to. Okay. Any questions about that? Any comments? Any questions about anything else, like on campus, anything going on, anything at all? Okay, well, if you guys don't have any questions, I'm going to let you go. Have a good weekend. Make sure to get that homework done, and I will see you all on Tuesday. And